rule, one of the rules. Another rule of probability says that the probability of a number or an event cannot be outside of 1 and 0. So if I'm drawing a number line, and this is 0 and this is 1, oh, this line is a crooked line. All right, so this is 1. This is saying that the probability of an event is not allowed to be below 0, and it's not allowed to be above 1. Therefore, the probability must be from here to 1, from 0 to 1. So if you calculate the probability of an event, it can be 0.01, it can be 0.2, it can be 0.5, it can be whatever, provided it is between this range. When you calculate the probability of an event and it is 1 point something, well, you made a mistake. Something is wrong with the calculation, because the probability of an event is not allowed to be more than 1. The probability of an event, E, it cannot be greater than 1. The probability of an event, E, cannot be greater than 1. Also, the probability of an event, E, is not allowed to be less than 0. So that is what this is saying. It's saying both of this. It can be between 0 and 1, but it cannot be more than 1. It cannot be less than 0. Being less than 0 means it cannot be negative. So the probability of an event cannot be negative. It cannot be greater than 1. The sum of all the probabilities must be 1. So that is question number 1. Question is given. Remember, this is remember that a final exam is cumulative and comprehensive. So all the units are in here, units 1 to unit 4. Select about 20 questions to be in that test, of about 16 questions. There will be about 4 questions from each unit. 4 questions from each unit. All right, so that's number 1. Let's go to number 2. Exam review number 2. A probability experiment is conducted in which the sample space of the experiment is this. Sample space is these numbers, and they are all integers. So the sample space, they are all integers. Let event E, so event E is also all integers. Assume each outcome is equally likely. List the outcome of E complement. So remember, whenever you are told to find E complement, it is always, okay, the probability of E complement, or just E complement. E complement is 1 minus E. Or go to the sample space given to you, minus everything E, minus everything E. This is not probability, so that's why I'm not writing probability there. All right, so what we're going to do is I am just going to eliminate every number in E, take it away from the sample space. I will take away every number in E from the sample space. The remainder will be E complement. The remainder will be E complement. So let's do that now. I am going to take away, about to clean. So I'm going to clean and make space for taking away the E's out of the sample space. Remember, the sample space means the total of everything that you're looking for. All right, so the first number in E is 8. Let me get 8 and 9 at a time. So 8 and 9. So 8 and 9. I have taken 8 and 9 away. Let me take 11 and 10 and 11. 10 and 11 are in E. 10 and 11 will be taken away from here. 12 and 13 are in E. 12 and 13 will be taken away from here. Therefore, E complement are all the remainders from the sample space. E complement is everything remaining in the sample space because I have taken away all the members of E. And so I have 6, 7, 14, 15, 16, and 17. So all these are E complements. All these are E complements. Everything in the sample space that does not belong to E. Everything in sample space that does not belong to E is E complement. I will list everything I have just done in A. So my answer is A. And E complement is not an empty space. It's not an empty space because I found numbers in the sample space that are not in E. All the numbers in the sample space that are not in E are E complement. Okay, so let's get clean all this. So we have done numbers 1 and 2. All these are what we studied in this semester. So doing it will help you. Make sure you do all the numbers. Okay, so we found the E complement. E complement is everything in the sample space that does not contain E. All right, so number 3, suppose that E and F are two events and that the probability of E and F is 0.1 and the probability of E is 0.4. What is the probability of F given that E will happen first? So if you remember, number 3 is a conditional probability. Conditional probability. And you have to know how to write the formula. So let's go ahead and write the formula for number 3. That's the first thing you have to do. Write the formula for conditional probability because it is a probability distribution. All right, so let me do that. The probability of F, given that E will happen first, is equal to the probability of F intersection E divided by the probability of E. Remember that denominator is the probability of E. The probability of the one that happened first should be in the denominator. The intersection of both of them will be in the numerator. All right, so now that we have written the conditional probability, we want to put in the numbers given to us. So we are given that the conditional probability or the probability of E and F is 0.1. So we write 0.1 here. And then the probability of E alone is 0.4. That is in the denominator. Therefore, I can find the probability of F given that E happens first. So if you look at it, it is 1 over 4. 0.1 divided by 0.4 is 1 over 4. or 25%. If I'm told to give my answer in percent, type an integer or decimal. So I am just going to write 0.25. So that probability is 0.25. What is the probability of F given that E happened first? Therefore, the probability of F given that E happens first is 0.25. All right, question number 4. Find the value of the permutation. Find the value of the permutation. All right, so this time I am told to find the value of the permutation. So what I'm going to do is remember the formula for permutation, and it is n permutation r is equal to n factorial over n minus r factorial. All right, if I write it out, well, I can use the numbers given to me. Therefore, 7 permutation 7 will give me 7 factorial all over 7 minus 7 factorial. All over 7 minus 7 factorial. All right, so 7 factorial over 0 factorial. Everybody remember that 0 factorial is 1. We emphasized it in this class. 0 factorial is 1. I hope you're not going to say that this is undefined, because 0 factorial is 1. And remember, you can do this with your calculator. So you go to your calculator and go to math, M-A-T-H, and arrow to probability, and number 4. So I'm going to clean this. I want to write 7 first. 7, go to math, arrow to probability, and number 4, which is factorial. I don't have to divide by 0 factorial because I already know that 0 factorial is 1. So, and I see that is 5,040. Therefore, 7 factorial divided by 0 factorial is 5,040. 5,040. That's 7 factorial. In other words, if I have 7 things and I'm choosing 7 of them at a time, in how many ways can I choose 7 out of 7? In how many ways can I choose 7 out of 7? I can choose 7 out of 7 in 5,040 factorial ways. I can choose 7 out of 7 in 5,040 factorial ways. Okay, so that is exam review number 4. Let's see if somebody came in. If you're just coming in, just know we are reviewing for final exam, and final exam will be on, we'll start on the 3rd and finish on the 4th. Final exam will start on the 3rd and finish on the 4th. All right. So we have reviewed, and by the way, the next time for review, we are reviewing today, and we will review again on, let's see, today is the 25th. Today is the 25th. So next time we are going to review is going to be December 2, Monday, December 2. And after Monday, December 2, our final exam starts on Tuesday, and we'll finish on Wednesday. So the last day to review is a week from today. Final exam will start on Thursday, actually Tuesday, and finish on Wednesday. Okay. All right. So now we have done final exam review number 4. So let's go to another one. Final exam review. Let's go to another question. Number 5, a survey of 2,302 adults in a certain large city aged 18 and older, conducted by a reputable polling organization, found that 405, actually 415, have donated blood in the past 2 years. So the number that donated blood is one of the things we're looking for. X, number that donated blood is 415. And sample size is 2312. A large sample, okay? And they have donated blood in the past 2 years. Complete parts A through C. Question A, obtain a point estimate. So what is the point estimate? In other words, what is p hat? What is sample proportion? What is the sample proportion? Okay, and sample proportion is x over n. Therefore, I can as well say 415 over 2312. So I get my calculator and find what sample proportion is. So I have 415 divided by 2312. And I have an answer. So the probability of p hat, the p hat is 0.179. I can do it 0.1795. So that probability p hat is 0.1795. Let me see, round to 3 decimal places. If I round to 3 decimal places, then I have 0.179. So 0.179. Okay. So the p hat is 0.179. Verify the requirement for constructing a confidence interval about p. Okay, so what are the requirements? The sample is given to me is 2312. Okay, a simple random sample. The value of 2, what is C2 is, which is that? Let me just make sure, less than. I want to make sure that. So the important thing is, does NPQ, is NPQ greater than or equal to 10? So N times P times Q, all in hats, is it greater than or equal to 10? Let's check that. What is N? N is 2312. What is Q? Q is 0.1 SP, 0.179. And Q multiplied by Q is 1 minus 0.979. So I'm going to pull my calculator up. So I have 1 minus, second answer. Hope it's going to pull it up for us. All right. And I have, okay. So 1 minus 0.17975. And what I'm looking for is the probability of failure, 0.82. I can make that 0.821. So 0.821, I am trying to check the condition. Did he make the condition for hypothesis testing and confidence interval? That's what it's trying to ask me. So 2, 3, 1, 2 multiplied by 0.1795 multiplied by 0.821. So if I hit enter, the NPQ is actually 340, a whopping 341 if I round up. Therefore, it is greater than 10. It has met the condition number 1. Because it has met the condition number 1, I can do confidence interval. Also, the sample is small compared with the population of America. 2,302 is not up to 5% of 360 million. Therefore, we will agree that we can do hypothesis testing. All right, now that we have done the check, we will go quickly and do construct and interpret the 90% confidence interval of this data. So let's construct a 90% confidence interval of this population proportion. So because the sample has met the conditions for inference, I am now going to do confidence interval of this data. So I'll do 90% confidence interval. And this is one prop Z interval because it met the conditions. It met the conditions, so it's one prop Z interval. And it's asking me what is the number of people who donated blood. It is 415. What is the sample space? 2312. And what is the confidence level? 90% confidence level. And I'm told to calculate the confidence interval. So I'm going to calculate. Therefore, the lower end or lower bound of confidence interval is 0.1664. Right? So in C, so the lower bound is 0.1664, upper bound is 0.193. So I'm just going to put it here, 0.166. It's a leave my answer to how many decimal places. I want to know. Okay. Okay, this is 166 here. And if I get my answer again, I have 193 approximately. 193 is the upper bound, 0.193. Okay, so now I can say I am 90% confident. I am 90% confident, 0.9 or 90%, put it here. Therefore, I am 90% confident that the proportion of adults in the country aged 18 and older that took the give blood, or who are ready to give blood, who have donated blood, lies between 16.6% and 19.3%. If I can put it in percentage. Okay, so you have to be percentage, use the number of confidence interval given to you. I'm 90% confident because that is the confidence level given to you. Or you can say there is a 90% chance the proportion of adults in the country aged 18 and older who have donated blood in the past 2 years is between. I am 90% confident is the correct answer. Remember, there are answers at the back, so you can check. You go back and check the answer. Okay, this is final exam review. So notice that we also have linear regression here. We also have linear regression here. And this is a group data. So remember, we already did this. you want to make sure you know how to, you remember how to group data. You also remember. So what I'm going to do, I first of all make this data stand up. I just make the data stand up. So the first class is 50 to 59, and the days is 4. Second class is 60 to 69, and the days is 319. The third class is 70 to 79, and the number of days is 1466. The fourth class is 80 to 89, and the number of days is 1481, and the fifth class is 90 to 99, and the number of days is 220. Um, and the next class is 100 to 109 to 109, and the number of days there is 13. Okay, so first of all, rewrite the data so that it can be vertical. Change the vertical from the data from horizontal to vertical. So you already know, because this is review, you already know that after this you create class midpoint. What is the class midpoint of each data? And by the way, what is the class weight? The consecutive difference between lower limits is 10. Therefore, class weight is 10. So class weight is 10. Class weight is 10. So if the class weight is 10, what is the class midpoint? Upper class limit plus lower class limit divided by 2, and you have 54.5. So the first class midpoint is 54.5. You can put it in calculator. See, sometimes you want to make sure that you're right, because any small mistake can throw you off. So if I'm calculating the class midpoint, I'll calculate the first class midpoint, and that is 50 plus 59, and I get an answer. Then divide 109 by 2. So it has to correspond with what we got. So 54.5 is the first class midpoint. Now, something we do know is that the class width is 10. Therefore, the next class midpoint is going to be 54.5 plus 10, 64.5. The next class width is 74.5 because they differ by the class width. The next class width is 84.5. The next one will be 94.5. And the next one will be 104.5. So we got all the class width. And what we are looking for is the mean and standard deviation in question A. Find the mean and standard deviation. All right, so we can do that. We just pull our calculator up and put all the class midpoints in L1. So I'm going to go to Start, Edit, clear L1. Clear L2 first. I'm clearing L1 next because I don't need it. And then the class midpoint is 54.5, 54.5. The next one is 64.5. And the next one is 74.5. And the next one is 84.5. And the next one is 94.5. And the next one is 104.5. So I have all the class midpoints in L1. Now the next one I need are the frequencies in L2. The frequencies this time are the number of days for each class. So the first class is 4, second class is 319, third class is 1466, the fourth class is 1481, the fifth class is 220, and the sixth class is 13. Okay, so when we finish entering the numbers, we want to make sure they are on the same horizontal level. Somebody can make a mistake. Eyeball the data you entered to see if you made a mistake. If you did not, then let's go. We keep on going. So the next thing we want to do is find the one variable start of L1 and L2. So go to Start, arrow to Calc, do one variable start of L1 and L2. So the list class midpoint is in L1. We have frequencies in L2, and therefore we are going to calculate. So let's calculate. And as soon as we calculate, we find the mean of the population. That's what we are looking for. And they told us to round our answer to 1 decimal point. So my answer is 79.2. That's the mean. And the population standard deviation is 7.7. Mean 79.2. 79.2. And the standard deviation is 7.7. 1 decimal, round to 1 decimal point. Draw a frequency histogram of the data to verify that the distribution is bell-shaped. So, well, let's see. I can draw it in my calculator, but I can just also look at what they did. When I finish drawing in my calculator, I'll check what they did. It looks like it's going to be this, but let me check, and then I'll come back to confirm. So I can pull my calculator up, and I'll ask my calculator to draw a frequency histogram for me. And I will select plot 1 here. And this time I'll arrow down to histogram. And I'll select that. And then I will arrow down also and select L1, L2. So L2 because I have frequency. All right. And now I'm going to zoom 9 first. So zoom 9. So I have the argument. So I'm going to get away. Then zoom 9 on the main screen. So I have something that looks like, but that's not what I want. It doesn't look like histogram. Histogram have common boundary line. In other words, I have to do something to that. I'll go to my windows. I know that the class width is 10. So I want to make sure that I go to my class width and put 10 there. So I have to go to my X scale and put 10 there because the class width is 10. That's one thing I need to do. And because I have just done that, I will just not zoom 9 again. I will just graph. All right, so my diagram, my histogram looks like C. Therefore, this data is bell-shaped. The data is bell-shaped. Another way I can confirm is by checking the mean and the median. Okay, is the distribution bell-shaped? Yes. The frequency histogram of the data is bell-shaped. Yes. Okay, and according to the empirical rule, 95% of the data in this month will be between what two temperatures? Okay, so we said that this distribution is bell-shaped. So, and then I'm going to go to the mean. So I get to the mean now. Because we said it's bell-shaped, the mean is, well, let me go up and get the mean again. So the mean is 79.2. The standard deviation is 7.7. So the question is, what percentage lies within 9.95%? In other words, 79.2 plus or minus two standard deviations. So here I'll put 79.2 minus two standard deviations, minus 2 times 7.7. That is going to be the lower bound. And then here I will have the mean 79.2 plus 2 times 7.7. And then when I get that answer, that is going to be my answer. You can look at the key. Remember that this is okay. So 2 multiply 7.7. I hope you know that this is 7.7. So I am going to do this arithmetic in my calculator. So I'm just going to clear that. And then the mean is 79.2. 79.2. All right, so I'll say minus parenthesis 2 multiplied by 7.7 close parenthesis, and I will have the lower bound, so I'll put 63.0 here, 63.0, and then I go to the upper bound, put my calculator again, and then I will put in the number 79.2, 79.2 plus, and then I am going to put parentheses there, parentheses 2 multiply standard deviation 7.7 close parentheses. When I hit enter, I'll get 94.6. Therefore, from 63 to 94.6 contain 95% of the data. There are plus or minus 2 standard deviations. They contain 95% of data. So I have 94.6. 94.6. The 94.6. All right, so, and now that's all. Fill the blank to complete number 7. Fill the blank to complete the, so we have answered this question, by the way. We remember question number 6, we said 95% of the data that contains plus or minus 2 standard deviation is from 63 to 94.6. All right. Okay, fill in the blank spaces for number 7. If we reject the null hypothesis when the statement in the null hypothesis is true, we have made a type 1 error, type 1 error or alpha error. If we reject the null hypothesis when the statement in the null hypothesis is true, type 1 error, type 1 error. Okay, so that's number 7, so easy to answer. Let me see how many questions are here. So there are a maximum of 20. In other words, we are going to finish it by next class. I don't intend to do all of them though. So next class we shall be here we shall be doing a confidence interval and hypothesis testing. We shall be doing confidence interval and hypothesis testing. All right. Next time we shall be doing confidence interval. So we started the exam review today. We shall be doing confidence interval and hypothesis testing next class.